Hi everybody. We are going to look at trig functions of any angle. If you recall, we have found like sine, cosine, tangents, but those angles have all come out of from 0 to 90, and so now we're going to look all the way around the unit circle. We've already talked about this graph, talking about how sine and cosine is x value, sine is our y value, tangent's y over x. But then when we talk about graphing coordinates, our x and our y functions are both positive here. They're both one of each in the second quadrant. They're both negative in our third quadrant, but that makes tangent positive. And then our one of each, which makes tangent negative. So this isn't new. This should feel pretty familiar to you. Again, if I'm going too fast, just pause the video real quick. But if we find out which quadrant does theta lie in, well, if sine is greater than 0, that means that sine is positive, and cosine is greater than 0, that means cosine is positive. So which quadrant is both sine and cosine positive in? Quadrant 1. And so that is where we would draw our triangle. Okay. Look at this one. When is tangent less than 0? So when is tangent negative? And cosecant, remember, is the reciprocal of sine. And so when is sine also negative, or cosecant negative? Well, tangent is negative in quadrants 2 and 4, but sine is negative in quadrant 4. So we are talking quadrant 4. Okay, so that's a quick review for you. How are we going to use this? Well, now we're going to talk about a reference triangle. And a reference triangle is coming up with a triangle based off of the coordinates x and y. It always will come out of your origin for the radius or your hypotenuse, and this is your x function, and this is your y value. So this is the point over x of y. Okay? Again, we're always using 0, 0, and theta will always come out of the origin. Okay? So again, that's where we've come up with our whole toa part of things. The only difference is we've labeled them adjacent, opposite, and hypotenuse. Okay? So, let's try an example here. If I told you to make a reference triangle using 3, 4, okay, well, that means we're going over 3, up 4. So that is the point over 3, up 4. And now that gives us our hypotenuse. That gives us the rest of our triangle, and there's theta. We went over 3, up 4. And now, how do you find the missing side of a right triangle? A squared plus b squared equals c squared. This is one you should have memorized. Those of you who are going into any sort of framing or building, we call these 3, 4, 5 triangles. Again, if it helps, label the sides. This is your adjacent, this is your opposite, and this is your hypotenuse. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. That should feel very familiar, okay? There really is nothing new to this whole unit today, other than now we're going to draw reference angles or triangles in a different quadrant. So let's look at the second example. The second example says to draw a triangle from -5 to -12. Well, if I plot the points negative 5, negative 12, that means I'm going to the left 5 and down 12. So now there is my new radius or my hypotenuse, and there's the rest of my triangle. I went over 5, down 12. Now the thing you need to remember is when we do a squared plus b squared equals c squared, these now become positives. Because negative 5 times negative 5 is positive 25. And negative 12 times negative 12 is positive 144. So this gives us 169. And the square root of 169 is 13. The other thing is your hypotenuse is your radius, and radius can't ever be negative because it's a distance. So that's also something to make sure you keep in mind. And now theta, remember, always comes out of the origin. So this is my adjacent, opposite, hypotenuse. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And make sure a negative divided by a negative becomes positive. Cosecant then is negative 13/12. Secant is negative 13/5. And cotangent is 5/12. So again, this shouldn't feel anything too difficult. Okay, let me add one more twist to all of this. And you set up the triangle for 2, negative 2. A squared plus b squared equals c squared. 4 plus 4 is 8, and we have the square root of 8. Let's go back a few weeks ago. How do I simplify the square root of 8? We don't want the decimal, but we can take a perfect square out of it. The square root of 8 is the same as the square root of 4 times the square root of 2. Square root of 4 is 2, and now we have 2 square roots of 2. Again, it's going to be positive because it's my radius. So now when I find my trig functions, this is my adjacent, opposite, and hypotenuse. Sine is going to be opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. What are we finding here? We're going to have to do some rationalizing. So let's review how to rationalize. Tangent's easy. A negative divided by a positive 2 is negative 1. When I simplify this, I can reduce this to a negative 1 and then multiply the both top and bottom by the square root of 2. Negative 1 times the square root of 2 is negative 1 square root of 2. Square root of 2 times the square root of 2 is the square root of 4, which is 2. And why can't I simplify my 2's? Because one's a radical and one's a number. Same thing here. 2 divided by 2 is 1. Multiply top and bottom by the square root of 2. 1 times the square root of 2 is the square root of 2. And this gives me the square root of 4, which is 2. Now, when I go to put in my cosecant, if I reciprocate this, I'm going to have to go back to rationalizing again. So if I were you, I would flip this right here. So this becomes square root of 2 over negative 1. Secant, again, flip this part right here, square root of 2 over positive 1. And cotangent, negative 1, flip this to negative 1. So that's the only twist to anything like this today. Hopefully it just feels like a good review day.